Okay, so we are going to cover section 2.6, and this is on implicit functions. Implicit functions and implicit differentiation. Okay, so let me start with the following. If you have an equation in two variables x and y, can be expressed as a function of two variables x and y equals to 0. In other words, whatever equation you have in x and y, you can put all the terms on the left-hand side and make the right-hand side 0, right? So what is f of xy? That's just some expression involving x and y. So for example, if I have the equation, let's say the equation of the circle of radius 2 centered at the origin, this equation, then I can express that equation as x squared plus y squared minus 4 equal to 0, and then this left hand side is what I'm calling f of xy, right? So any equation you have, you can write that equation as certain expression involving x and y equals to 0. Is everybody okay? Now, what is this f of xy? That's actually a function of two variables. When you go to Calc 3, if you have to take Calculus 3, you'll see functions of 2 variables, 3 variables, 1,000 variables. So if you think about this expression here, what is an input value for a function like this? The input value is a point, so an x value and a y value. So the input value is a point, and the output value is just a real number. So if I give you the point 1 and 2, if you plug in here, you get a real number, right? Am I making sense? So this is a function of two variables because the input is a point. The input is a point. The output is a real number. You can also think about the input being, a point in space, right? And the output is a real number. So this is a function of two variables, and you'll see those in Calc 3. So where do you want to go? Where do I want to go from here? I want to consider graphs of equations in two variables. If I give you an equation, and if you look at the graph of that equation, is that generally a function? That is, you look at the graph, does that represent y as a function of x? So generally speaking, the graph of an equation f of xy equals to 0 doesn't represent y as a function of x. So an example of that is the equation that we just looked at. If I look at the equation x squared plus y squared equals to 4, what's the graph of that? The graph of that is simply a circle, and this is a circle of radius what? Centered at the origin, right? So this is a circle of radius 2 centered at the origin, and the graph of this equation is the entire circle. So this curve does not represent a function, right? This curve does not represent y as a function of x, right? Am I making sense? Why doesn't it represent a y as a function of x? Because it doesn't satisfy what? It doesn't satisfy. So if I take an arbitrary value of x, there are 2 points corresponding to that value on the graph, right? So this doesn't represent y as a function of x, because there are 2 distinct values of y corresponding to the same input value x, right? Is everybody okay? So it doesn't represent a function. However, notice that whoops. Okay, yeah. So however, notice that so the entire circle doesn't represent y as a function of x. However, note that if I take the upper part of the circle, that represents y as a function of x, just the upper part of the circle. And also if I look at the lower part of the circle, that also represents y as a function of x, right? Can you give me a formula for the green part? Can you express y explicitly so that the graph of that function y would be the green part? This is the graph of which function? The green part is the graph of which function? Well, I can see, right? I have x squared plus y squared is 4, right? Can you solve for y? Y squared would be what? This, and then what is y? Yeah, the plus or minus of that. And when you take plus, you get the upper half of the circle. So the graph of the function the graph of the function whose graph is the green curve is given, the formula for the function whose graph is the upper part of the circle is given by that. And what's the formula for the lower part of the circle? That's the function which is negative root of 4 minus x squared, right? Is everybody okay? So even though the entire circle doesn't represent y as a function of x, we can break up the circle into, in this case, 2 parts, where each part represents y as a function of x, right? Is everybody okay with that? Now, how did I break up? What are the points where I broke up the circle? Which points? Well, those are the points right here, right? And right here, right? So notice that not only that I can break up the circle into 2 parts where each part is a function, notice that if I pick any point on the curve except for the red points. If I pick any other point on the curve, I can always find a part of the curve containing that point where y can be viewed as a function of x. Is that making sense? If I pick any point on the circle except for the red points, I can find a part of the circle around that point where y can be viewed as a function of x. But if you look at the red points, no matter what part you pick of the circle containing the red point as an interior point, it cannot represent y as a function of x. You realize that? No matter how small part I pick around a red point, it cannot represent y as a function of x because it's not going to satisfy the vertical line test. You realize that? So what's going on at the red points? What's going on at the red points? What is different about the red points than the other points? So what I have so if I pick a part of the circle containing one of the red points as an interior point, it doesn't represent y as a function of x. However, if I pick any point which is not one of the red points, then you can always find a part containing that point where you can view y as a function of x. My question is, what is different about the red points? Yeah. But just because you have x-intercept, I can, make up examples where you might have x-intercepts, but doesn't mean that you cannot make a function containing those points. Yeah. Even not that, because it might cross. So what he's saying is that at the red points you cannot get a function. So if I take a part of the circle containing the red point, I cannot get a function because I have the curve in two different quadrants. But remember, if you have a graph of a function, the graph of a function can go through all quadrants, right? So that's not the reason. Why is it, why can't, if I take a part of the circle containing a red point, why can't it satisfy the vertical line test? Well, if you think about it in terms of the tangent lines, right? What's the tangent line at a red point? It's a vertical tangent. So if you look at the tangents at the two red points, the tangent lines are vertical there. So whenever you have a vertical tangent, so that would mean that it may be that the curve goes like this, right? Am I making sense? So at the red points you have vertical tangents, and as long as you pick a point where the tangent line is not vertical, you can always find a part of the curve around that point where y can be viewed as a function of x. Can someone tell me the coordinates of this point here, the red point here? Negative 2, 0, right? And this would be the 2, 0 point. So except for those 2 points, so away from those 2 points, I can view y as a function of x. Away from those 2 points, I can view y as a function of x. Let's look at another example. Let's look at the equation x equals to y squared. And what's the graph of that? The graph of that equation, anybody knows? Yeah, it's a parabola that opens what? To the right, like this. So that's the parabola. Now, what's the tangent at this point here? At the red point here, the tangent is what? Is in fact the y-axis, right? So it's the vertical tangent. Now, again, this the graph of this equation does not represent a function, right? It doesn't represent a function. However, if I take two parts like I did before, so if I take this part here, and also if I take this part here, individually both parts represents what? Functions, right? And can someone give me a formula for the green curve? Y is equal to negative of the radical of x. And what would be a formula for the other one? What's that? Positive radical of x. Very good. So even though the entire curve doesn't represent y as a function of x, I can break it into two parts where each part represents y as a function of x. Again, where did I break up the curve? I broke it up at the point where the tangent is a vertical tangent, right? Is everybody okay? Now, notice that, again here, notice that if I pick any point which is not the red point, pick any point which is not the red point, then you can always find a part of the graph where you can view y as a function of x, right? But if you pick the red point, no matter how small portion of the curve you pick containing a red point, it cannot represent y as a function of x. Is that okay? Everybody is doing okay with that? Now, what's the point of all this? Well, my point is the graph of an equation generally does not represent y as a function of x. However, parts of the graph do represent y as a function of x, right? So the function, the purple, is that a purple color? I don't know. The purple part represents y as a function of x. The green part represents y as a function of x as well. We say that these two functions are implicitly defined by this equation. We say both of these functions are implicitly defined by that equation. Now in this case, we were able to give explicit formulas for the functions, right? There are two functions which are implicitly defined by this equation, and we can find explicit formulas for both functions. But usually you cannot even find explicit formulas for these functions, okay? So here's an example of well, let me make up an example here. So let's say a sine of x plus y is equal to 4, right? If I have that equation, again, the graph of that equation may not represent y as a function of x, but there will be parts of the graph of that equation may represent y as a function of x. And in this case, I cannot find explicit formulas for those functions. Am I making sense? In my previous two cases, circle and the parabola, I was able to find explicit formulas for the two functions that I saw that can be that were defined implicitly by the equation. But if I have this equation, you cannot find explicitly what y is. Am I making sense? But if you look at the graph, there are parts of the graph where you can view y as a function of x. You just cannot find an explicit formula. Is that making sense? Okay, so there are functions which are implicitly defined by equations. Then the question, and these implicit functions, they do appear in many places in applications, right? In the economics, and even in physics, and I'm pretty sure even in engineering, you'll see that implicit functions appear. If you have implicit functions, then what do you want to know? Well, you would want to know the rate of change of that function. You would want to know what's the derivative of that function. Okay? So that's where implicit differentiation comes in. So first of all, let me recap what I said so far. The graph of an equation f of xy equals to 0 doesn't generally represent y as a function of x. However, the graph can be broken up into parts where y may be viewed as a function of x. Does that make sense? And these functions are said to be implicitly defined by the equation f of xy equals to 0. So even though you don't have an explicit formula for y in terms of x, notice that if you think of y as a function of x, this equation defines a relationship between the input and the output, right? It tells you that the input value of the function and the output value of the function, they satisfy this equation. Am I making sense? And the question then is, how would you find the derivative of y with respect to x for these implicit functions? The good thing is, even though there are more than one functions that are implicitly defined by the equation, right? There are more than one functions. You can find the derivative of all these implicit functions at once. Okay? So let's see how. So let's go back to our example of the circle. Now, this is not a good example because we know that in the case of a circle, I was able to find a formula, an explicit formula for y, right? Plus root of that or minus root of 4 minus x squared, right? And then I can take the derivatives of those two functions separately to find the derivative of the two implicit functions, right? Am I making sense? However, let's say you didn't know how to find y explicitly. How would you find the derivative of y with respect to x? So find the derivative of y with respect to x. So the moment you are asked to find dy dx, remember you are viewing y as a function of x. Okay, you are viewing y as a function of x. So how would you find the derivative? First of all, I am going to emphasize the fact that I am viewing y as a function of x. So I'm going to write y of x just to emphasize the dependence of y on x, that y is a function of x. Okay? And now I take I'm going to, if both sides are equal, right? Now, the left-hand side is a function of x because I'm viewing y as a function of x. The right-hand side is a function of x, so I can take the derivative of both sides with respect to x. So if I take the derivative of the left-hand side with respect to x, I can take the derivative term by term, right? So I can take the derivative of x squared, plus I take the derivative of the second term, which is y of x squared. And what's the derivative of 4? Yeah, the derivative of 4 would be 0. Now, okay, so the derivative of the 4 would be 0. Let me write that down right now. And what's the derivative of x squared? 2x. Okay, that's easy. But what's the derivative of y squared? Notice that I am taking the derivative of y squared with respect to not y, right? I'm taking the derivative with respect to x, not y. So the derivative, if you use, so you look at, so what is y of x? Y of x is some function of x, right? So you look at this expression, you're taking the derivative with respect to x, you would wish this was x squared, right? If this was x squared, then the derivative would be what? Derivative would be 2 times x, right? 2 times x. That would be the derivative if y of x was just x. But by chain rule, then you would have to multiply by the derivative of the quantity that you wished was x, right? So this would be what? Y prime of x, right? So I'm applying the chain rule. The derivative of y squared would be 2y times the derivative of y with respect to x. So what is that? This is 2x plus 2 times y times y prime of x. Another notation for that is dy dx, right? And once I have this, I can solve for dy dx. So I get 2y dy dx is equal to negative 2x. And then dy dx would be negative 2x over 2y, which is negative x over y. Is everybody okay with that? Is everyone okay? Any questions? Everyone says how implicit. The way I computed the derivative, this is called implicit differentiation, okay? Is everybody okay? Any questions at all? Now, when you took the derivative, so let me emphasize what we did here. When we, so this is just a discussion here, remark. If I take the derivative of y squared, if I take the derivative of y squared with respect to y, then it is just 2y, right? It is just 2y. But if I take the derivative of y squared with respect to x, we are assuming that y is some function of x. Then it is, you take the derivative as usual with respect to y, and then you multiply by what? Then you multiply by dy dx. Is that making sense to you? It is really the chain rule. That is, when you are taking the derivative with respect to x of y squared, right? This is the same as you instead of, you see, you have a function in y, right? You have a function in y, so you can take the derivative with respect to y first, and then you have to multiply by dy dx. This is by chain rule, right? You take the derivative with respect to y first, and then you multiply by the derivative of y with respect to x, because you want the derivative with respect to x, not with respect to y. Am I making sense? So if you're taking the derivative with respect to y, then the answer is just this, 2y. Otherwise, it'll be 2y dy dx. Okay, if you have any questions, please go ahead and ask. Let's look at another example. Let's say I have the equation x equals to y squared. Remember, that was the parabola. And again, the same question. Find the derivative of y with respect to x. Okay, so how would I find it? Well, I take the derivative of both sides with respect to x, right? So I take the derivative of the left-hand side, I take the derivative of the right-hand side, and the derivative of the left-hand side is what? 1. Now, you're taking the derivative of y squared with respect to x, so you take the derivative of that with respect to y, as usual, which is 2y, and then you multiply by the derivative of y with respect to x. And then in this case I get dy dx is what? Dy dx is 1 over 2y. Is everybody okay with that? So there are two parts to this implicit differentiation. First of all, you have to take the derivatives, and then you have to solve for dy dx, right? So you have to do some calculus, and then you have to do some algebra. Here's another example. Let's say I have x equals to y cubed minus 4y. And again, the same question, you want to find dy dx. Okay, so how do I find the dy dx? Well, I just take the derivative of both sides with respect to x, and I take the derivative of this side with respect to x. What's the derivative of the left hand side? 1. Okay, what's the derivative of y cubed minus 4y with respect to x? Well, you take the derivative, the entire expression is in terms of y, right? So you take the derivative with respect to y first, which is what? 3y squared minus 4, but then you have to multiply by what? Dy dx. And then you could say that dy dx is 1 over 3y squared minus 4. Is everybody okay with that? Okay, let's look at a little bit harder example. Here's an example. Say I have x cubed plus y cubed is equal to 6xy. Okay, and what I want to do is again find dy dx. Okay, so what do? Well, I have to take the derivative of both sides with respect to x, right? I take the derivative of the left hand side, and I take the derivative of the right hand side. And what's the derivative of the left-hand side then? Well, I have a sum, but I can take the derivative one term at a time. So I take the derivative of x cubed plus the derivative of y cubed. Here, I am going to factor out the 6. You don't have to factor out the 6, but I'm going to write it this way. Oh, you know what? Should I? Well, let's not factor it out, okay? I'll just keep it the way it is. So you take the derivative with respect to x of 6xy. Now, what's the derivative of x cubed? 3x squared. What's the derivative of y cubed? 3y squared and dy dx, right? And what's the derivative of 6xy? Here, usually people make a lot of mistakes. Remember, you are trying to find dy dx. That means you are viewing y as a function of x. You don't have an explicit formula for y in terms of x, but you are viewing y as some function of x, right? So here, you would have to view this function as the product of two functions, okay? You have to view 6xy as the product of two functions, 6x and y. These are two functions of x. Now, you apply what? Product rule. So if I apply the product rule, what is that? You take the derivative of the first factor, which is what? Multiplied by the second factor as it is, plus the first factor as it is, multiplied by what? The derivative of the second factor, which is in this case, you write dy dx. Okay, I am done with calculus, right? I took the derivatives. Now, the rest is algebra. And let me tell you this. A whole lot of exam solutions I see, people have done the calculus correctly, and then they cannot solve for dy dx, okay? And the reason you wouldn't be able to solve for dy dx in exam is because you didn't do enough practice before the exam. Okay, you have to do enough practice with this problem so that you have enough practice with the algebra, so that when you do it in the exam, you wouldn't have trouble carrying out the algebra. So here, I have to solve for dy dx. So how do I solve for dy dx? Whatever you're trying to solve, put all those terms on the left side and everything else on the right side, right? So you're trying to solve for dy dx. So put all the terms involving dy dx on the left, and you have 6y minus 3x squared. Again, some words of warning here. Sometimes I see people canceling x and x. These dy dx, dx, they don't represent numbers, right? This is just a symbol for the derivative. They don't represent numbers. X represents a number, but the dx there doesn't represent a number, so you cannot cancel out. All right, so this is what? I factor out what? I have to factor out dy dx, right? So I have dy dx here, dy dx here. I have to factor that out. What do I get? 3y squared minus 6x times dy dx. You agree with that? And then I get 6y minus 3x squared. And finally, what is dy dx? Six y minus 3x squared over 3y squared minus 6x. Okay, so that's the derivative of this derivative of y with respect to x. Now, if I ask you to find the derivative at a given point on the graph of the equation. So, for example, you might be asked. Okay, so maybe the question is the following: find the slope of the tangent line to the graph of x cubed plus y cubed equals to 6xy. So you have to find the slope of the tangent line to the graph of this equation at the point 3, 3. Okay? At the point 3, 3. So you are told that the point 3, 3 lies on the graph of this equation. Can I check too? I mean, how do I check that 3, 3 is on the graph? You just plug in and see if you get same sides, right? Okay, and that's the case here. So how do I find the slope of the tangent line at that point? Well, remember, this is the equation that I had in my example, right? And I found dy dx to be what? Yeah, so if I want to find the slope would be given by what? The value of the derivative at the point 3, 3. So basically, you have the derivative formula. You just plug in 3, 3. What do I get? 6 times 3 minus 3 times 3 squared over 3 times 3 squared minus 6 times 3. And what is that? It is -1 really, right? Because it's just the numerator and the denominator, they are negative of each other. So I get the slope being -1. Is everybody okay with that? We don't have much time left, but let me show you the graph of this equation and show you the point 3, 3, the location of that. You don't have to know the graph of these equations to solve these problems, but let me show you how the graph looks like. With my limited graphing drawing skills. So that's how the graph looks like, okay? And the point 3, 3 is something like this point here. So that's the point 3, 3. Am I making sense? So this is this is called a folium, I think. Folium. The graph of that equation x cubed plus y cubed is equal to 6xy. It looks like that. Okay. You should be able to start doing the homework problems from section 2.6 now. But I am going to be going over more examples tomorrow from this section before I move on to section 2.8.